This lesson is intended to be a brief introduction to quantiles and what they are used for in process control with control charts. And hello again to this lesson, which essentially has two learning objectives. After this lesson, you should know what quantiles are used for in statistical process control with quality control charts. And if we are already talking about what they are used for, then of course one also have to know what they are exactly and what special quantiles there are, like quartiles and percentiles. This lesson is divided into two chapters. In the first chapter, we get an overview of the use of quantiles, and in the second chapter, we look at what they are exactly and what special ones there are. Let's start with the question of what these quantiles are needed for in the context of statistical process control with control charts. Let's go through the steps you go through when you want to make a statement about the quality of a process or want to determine the warning and control limits of a control chart. As always, the starting point is a characteristic such as the diameter of a piston. This product feature has a tolerance that must be met with a high degree of certainty. To be able to make a statistical statement about the process or the process result, data that can be evaluated must first be collected. So, you can measure a sample of 50 parts like here. Put into a histogram, first insights into the distribution of the values can be seen. The process location, this means the mean value in relation to the nominal size, is one important parameter here. For a more detailed statistical evaluation, the value distribution must be described mathematically. One possibility for this would be the description as a normally distributed bell curve or Gaussian bell curve. To be able to assess when a process is out of control, limits must be defined. If one of these limits is exceeded, then this is an indication that the process is no longer under control. But where do you set these limits? Well, very simple. For example, you choose a so-called non-interference probability in the process of, for example, 99%. This means that there is a 99% probability that all values will be within these limits. Conversely, this means that the probability that a value is outside these limits is less than 1%. If such an improbable event occurs, this is, as already mentioned, an indication of an out-of-control process. These limits can be found using the formulas shown below for x lower and x upper. In addition to the mean value mu and the standard deviation sigma, the factor u is also required. And this factor u is the quantile that we need. Sometimes this factor is also abbreviated with the letter z or t. A quantile is sort of a location parameter in statistics. A certain proportion of the values is smaller than the quantile, the rest is larger. Values for these quantiles can be found in tables, for example for the standardized normal distribution or lots of other distributions. For example, the value where 99.5% of all values are on the left and 0.5% of all values are on the right. How to calculate these quantiles yourself or take them from a table is discussed in various other lessons. The only thing here is to understand what you need them for in practical use in the context of control charts. In this chapter, we look at a few special quantiles. This should make it a little clearer what quantiles are. As already mentioned, a quantile is a location parameter in statistics. A certain proportion of the values is smaller than the quantile, the rest is larger. For example, the median is a classic quantile. He divides the values in the middle. So, 50% of the values are on the left and 50% of the values are on the right. Therefore, the median is equivalent to the 50% quantile. If the area under the curve is set to 1, then one would speak of the 0.5 quantile. A quantile is not tied to a specific number or value, but can have any value. If a distribution is divided into 4 equal areas, then in each case one speaks of a quartile. Limits would then be, for example, the 0.25 quantile or the 0.75 quantile. The 0.5 quantile would again be the median. If the value distribution is not divided into 4 equal areas, but into 100, then this is referred to as percentiles. Percentiles are therefore integer quantiles. But it is also often the case that both terms are used side by side with the same meaning. Well, that was a lot of new information. Therefore, I would like to conclude by repeating the 3 most important key messages. Quantiles are needed, for example, to calculate the limits of control charts. Measured values form a probability distribution. Quantiles are cut points or limits dividing the range of such a probability distribution. They determine how many values in a distribution are above or below a certain limit. And the median is equal to the 0.5 quantile or the 50% percentile. If you found this lesson helpful, please let me know and leave a comment. Thank you for that, take care and see you next time. Bye!